Hello everyone and welcome back to my channel Get Creative, Keep Learning and Keep Growing. So our today's topic is data structures, graph and its terminologies. So let us move further. So let us move on towards the introduction of the graph. A graph is an abstract data structure that is used to implement the mathematical concepts of graph. So it is basically a collection of vertices, also called nodes, and edges that connects these vertices. A graph is often viewed as a generalization of the tree structure, where instead of having purely parent to child relationship between tree nodes, any kind of complex relationship can exist. So graphs are widely used to model any situation where entities or things are related to each other in pairs. For example, family trees in which the member nodes have an edge from parent to each of their children, or transportation networks in which nodes are airports, intersections, ports, etc. The edges can be airline flights, one-way roads, shipping routes, etc. So what is the definition of a graph? A graph G is defined as an ordered set of vertices V and edges E, okay, that connects these vertices. So figure below shows a graph with V of G. So what are the vertices here? A, B, C, D and E. And which are the edges here? A to B, B to C, A to D, B to D, D to E and C to E. Okay. So note that there are 5 vertices and 6 edges existing in this graph. Now graph is broadly classified into two types, directed graph and undirected graph. A graph can be directed or undirected. In an undirected graph, edges do not have any direction associated with it. If you see this previous figure, then you can see that this edge doesn't have any direction given. It's a plain edge, okay? It means what? No direction given means what? You can traverse from A to B and you can also traverse from B to A. So it is a bidirectional traversal. So it is an undirected graph. Okay. So if you see this figure 13.2, then you can see there are direction givens on the edges. So here you can traverse from A to B. Okay. But you cannot traverse back from B to A. This is invalid. Okay. Now similarly you can traverse from C to B, but you cannot traverse from B to C. Okay. So this is directed graph. So edges AB is said to initiate it from node A. So node A is the initial node, or you can call it as a source node, and it is terminated at node B. So you can call it as terminal node or destination node. Now let us move on towards the terminologies of the graph. So what are the adjacent nodes or neighbors? So for every edge E is equals to U comma V that connects node U to V, the node U and V are the endpoints and are said to be the adjacent nodes or neighbors. Means what? If there is a node U and there is a node V, then there is an edge connecting U and V, then these two nodes are adjacent nodes or neighbors. Okay. Now what is the degree of node? Degree of node U is the total number of edges containing the node U. For example, degree of U is 0 if there are no edges connecting node. Means the node U is the isolated node. Okay. Now what is a regular graph? It is a graph where each vertex has the same number of neighbors. That is Every node has the same degree. A regular graph with vertices of edges k is called as k-regular graph or a regular graph of degree k. For example, if you can see here, this is a zero regular graph, means what? Each node has zero neighbors. Okay. This is a one regular graph, means what? Each node has only one neighbor. Okay. This is a two regular graph, means what? Each node has two neighbors. Okay. So this is a two regular graph. This is one regular graph and this is zero regular graph. Now let us move further. Now let us see what is path. A path P written as P is equals to 0, V0, V1, V2 up to Vn of length n from node U to V is defined as a sequence of n plus 1 nodes. So here U is equals to V0 and V is equals to V1 and Vi minus 1 is adjacent to Vi for I is equals to 1, 2, 3. Means what? If we are traversing from U vertex to V vertex, then whatever the vertices comes in between are counted as the path. Now closed path, a path P is also known as a closed path if the edges have the same endpoints, that is V0 is equals to Vn. Now what is a simple path? A path P is known as a simple path if all the nodes in the path are distinct with the exception that V0 may be equal to Vn. If V0 is equals to Vn, then the path is called a closed simple path. Now what is cycle? A path in which the first and the last vertices are same. Okay, this is called a cycle. A simple cycle has no repeated edges or vertices except the first and last vertices. Okay. Now what is a connected graph? A graph is said to be connected if for any two vertices u comma v in capital V there is a path from u to v. That is to say that there are no isolated nodes in a connected graph. Means every node is connected to some or the other node. So connected graph that does not have any cycle is called as tree. Therefore a tree is treated as a special graph. Now what is a complete graph? A graph G is said to be complete if all its nodes are fully connected. That is, there is a path from one node to every other node in the graph. A complete graph has n into n minus 1 by 2 edges where n is the number of nodes in G. Now what is labeled graph or weighted graph? A graph is said to be labeled if every edge in the graph is assigned some data. So in a weighted graph, the edges of the graph are assigned some weight or length. The weight of an edge denoted by W of E is a positive value which indicates the cost of traversing the edge. So the next figure will show the weighted graph. Now what are multiple edges? Distinct edges which connect the same endpoints are called multiple edges. That is E of U comma V and E dash of U comma V. Means E and E dash both are connecting U and V, that is same vertices, are known as multiple edges of G. What is loop? An edge that has identical endpoints is called as loop. That is E is equals to U comma U. Means a vertices is connecting to the same vertices. Now what is multigraph? A graph with multiple edges and or loops is called as multigraph. Means a graph which is having multiple edges as well as loop. So the next figure will show you the multigraph. Now what is the size of a graph? Remember, the size of a graph is the total number of edges in it, not the vertices. Size of a graph depends on the total number of edges in it. Okay. Now this figure shows you multigraph, tree and weighted graph. So what is multigraph? Here if you can see, there are multiple edges. From C to D you have one edge E5. From C to D or D to C again you have one edge E6. So there are multiple edges, plus there is a loop. Means the edge start from B and ends at B. Okay. Now here is a tree. Tree means what? A graph without any loop is called tree. So if you can see, there is no loop in this graph, so it can be called as tree. So this is a multi-graph where multiple edges exist as well as loop exist. In tree, no loop exists, and in weighted graph, some sort of value is given to every edge, means the cost to traverse that edge. For example, if you want to traverse from A to B, it will cost 3 units. Whatever the units is fixed. If you want to traverse from C to B, then it will cost you 4 units, like that. Okay. So here we have seen the terminologies related to the graph. I hope you all have understood it. So our next topic will be directed graph. So stay tuned. Thank you and have a nice day ahead.